Okay, so in the example one, we're going to be graphing the function f of x equals 2 to the power of x. And as we said, the base is 2. And because the base is 2 and that 2 is more than 1, I can expect the graph to start very, very small and to kind of grow very, very quickly. Okay. To graph this function in this particular problem, I'm just going to be making a table. So I'm just going to replace the x with the number 1. 2 to the power of 1 is going to be 2. The next case is going to be 2 squared, and that's basically going to be 4. The next one is going to be 2 as a base, and the power is now 3. So 2 to the power of 3, that's going to be 2 times 2 times 2, which is going to be 8 at the end. Okay. Again, how am I getting these numbers over here? I'm getting them by doing this. I'm basically grabbing the number that was suggested in the table and I'm putting it in the power because that's what they want me to do. Okay, so I'm grabbing the number that was in the suggestion box and I'm putting it in the power. On the other hand, if I put in 0, I get 2 to the power of 0, which is gonna be 1. This is something that we need to know by default, right? Anything to the power of 0 is 1 except for 0 to the power of 0. That's undefined. Okay, if I have 2 to the power of negative 1, that's gonna be 1 over 2. And if I have negative 2, I get 2 to the negative 2, which is going to be 1 over 4. Okay, why is it 1 over 4? Okay, so 2 to the power of negative 2, that's the same thing as saying 1 over 2 with the positive 2 exponent, and that's going to be the same as 1/4. Okay, so that second table is a little bit more difficult, so I'll add an extra, explanation. Anything to the power of 0, any constant to the power of 0 will always be 1, except for 0 to the power of 0. I'm also using a negative exponent that says if I have a to the negative exponent, that's the same thing as a to the m positive exponent. Okay, so that's basically what I'm using to make the second table. But again, I'm using the numbers that they suggested. 0, plug it in, negative 1, plug it in, negative 2, plug it in. Okay, so now that we have all these answers, the 1, the 1/2, the 1/4, and all the ones from the other side, we're going to transfer them to the grid. Okay, so my numbers were 1 and it gave me a 2, the 2 gave me a 4, the 3 gave me an 8, and I had other numbers. The 0 gave me a 1, the negative 1 gave me 1/2, and the negative 2 gave me 1/4. I'm going to take them and plot them over here on this graph and see what happens. So 1 gave me a 2. When x was 1, I got a 2. 2 gave me a 4. When x was 2, I got a 4. When x was 3, I got an 8. And you can see it's growing very, very quickly. On the other hand, when x was 0, we got a 1. When x was 0, we got a 1. When x was negative 1, I got a 1/2. So if this is 1 right here, 1/2 would be about right there. When x is negative 1, we get 1/2. And when x is negative 2, we get 1/4. So if this is 1/2, 1/4 would be 1/2 of that amount. So negative 2 gave me a 1/4. You can see these points right here are super, super close to each other, whereas the other points are very far from each other. So at this point, all I have to do is basically connect the little graph dots together and we'll be basically finished. So when you make the graph, keep in mind that there's a horizontal asymptote, meaning there's a horizontal line that we cannot cross. Okay, so the horizontal line that we cannot cross is the x-axis. So that's going to be what we call the horizontal asymptote. The equation of this is y equal to 0. This is the horizontal asymptote. It's a line that works like the border, basically. And the graph is going to be what you get when you connect all the points with each other. So something like that, basically. As you can see, on the left, it is very, very, very small, very, very close to the red line. Whereas on the right, it shoots up and it becomes almost vertical. So very small here at the beginning, very small. Whereas at the end, it's going to be very large. The graph is always concave up and increasing. So the graph is concave up and increasing. That's why it has that curvy shape. And it looks like the yellow graph that we had on the previous page. Okay, it's connected everywhere. It's concave up, it's increasing, it's positive, starts very small, ends very large. That's the general shape. That's it.